Hello dear students, welcome to the fourth video lectures on structural design 1. In last video lectures, lecture number 3, we have discussed the all clauses related to design of bolted connections, and we have solved one numerical which covered the design of lap joint, butt joint with single cover plate and double cover plates. Okay, in this video lectures I am going to cover one more numerical which is slightly different than whatever we have discussed in the last lectures. Okay, so just start discussing the numericals. Okay, this is the design examples of simple bolted connections. Okay, in last lectures we have very detailed discussions of that design shear strength of the bolt, okay, VDSB, and we have calculated that VDSB is equal to FU by root 3 in bracket NN into ANB plus NS into ASB. Okay, so ANS, that we have put that value of NS is 0. So why it is 0? See, the equation given, VDSB equation given by the code is for such type of bolt. Okay, the bolt which is partially threaded. Okay, so this area is called as the shank, and this is the threaded parts. Okay, so that shank means ASB. Area of shank, that is this, for if this bolt is 20 mm diameter, then ASB is equal to pi by 4 20 square, it is 314 mm square. Okay, and that A and B net area of bolt is the A and B, which is equal to due to this threading, there is a area is going to be reduced over this plane section. That reduced area is considered by the code as 22%. So remaining area, net area of bolt is equal to 0.78 into pi by 4 20 square. That comes out to be 245 mm square. Okay, so this is the case. Okay, but we put that a value of NS is 0. So see, this is the practical examples of the bolt. Our practically bolt is like this. Okay, this is the length of the bolt, this is hexagonal head, and this is washers. Okay, and you observe that all length is completely threaded. Okay, so that's why we have put that NS shank, number of shank in failure plane has been 0. Okay, so this is the reason, because why bolt is like this. If we are providing the completely threaded bolts, then there is a uniform distribution of stress throughout the length of the bolt. Okay, so since there is no change in the area, the plastic hinge has been formed slightly at latter stage. But whereas in this case, see, this is there is a at this location there is a stress concentration, because there is a drastic change in the stress. Okay, so due to that drastic change in the stress, there is a formation of plastic hinges very early compared to this case. Okay, so that's why, that is the reason why we have put it that NS is equal to 0. Okay, so this is about the shear capacity of the bolt, the equation given by the code, that for partially threaded and fully threaded. Okay, so in this lecture I am going to discuss your in semester the numericals from your last year in semester examination paper. Okay, so this is your T in semester paper of structural design 1. These are the maximum marks for is 30 marks, and time is given 1.5 hours. Okay, these are the instructions you have given. You have to solve 3 questions. 6 questions are given, 1 or 2, 3 or 4, and 5 or 6. Okay, so you have to read the questions carefully, because selection of question is very important. Okay, otherwise you are losing the time. See, though the time is 1.5 hours, it is very less. Okay, if you are not planning your if you are not solving your question by proper planning. Okay, then FP410 grade of steel is given. Okay, this is applicable for all steel. Ultimate stress of bolt is FUB is given as 400 Newton per mm square, means 4.6 grade is given, grade of bolt. Assume suitable data if necessary. Most of the things may not be given, that we have to assume, and we have to mention it clearly in the solutions. Okay, then use of pocket calculator, IS 800-2007, and steel table is allowed. Okay, but again I am repeating, don't write anything on the steel table and IS code. Okay, that will be treated as a copy during the examination. Okay, okay, now let's discuss the question number 1. Question number 1A, state and explain types of steel structure with sketches. This is for 4 marks. Okay, so in that you have to write down the 4 types of steel structures with sketch, and you have to write around 1 or 2 sentences its answers. Okay, then next, a tension member of roof truss consists of two ISA 90 by 90 by 6 at 8.2 kg per meter, which is connected to 8 mm thick gusset plate by bolts. Design, connection and draw sketch. Okay, see, two ISA, there are two angles has been given. ISA means Indian standard angle, 90 by 90 by 6 is size, and at the rate 8.2 kg per meter means its running meter weight is given. Okay, which is connected to 8 mm thick gusset plates. Thickness of gusset plate is 8 mm. Okay, and design the connection and draw. See, for nothing is given, load is not given, diameter of bolt is not given, grade is not given, so you have to assume all these things and we have to mention in the your numericals. This is for 6 marks. Okay, now just discuss the numericals. The first questions, state and explain types of steel structure. So these are the types of steel structures: industrial building, commercial building, steel bridges, transmission oblique communication towers, steel water tanks, chimneys, bunkers and silos. Okay, from this, just you have to write down 4 to 5 types. You have to draw its neat sketch and you have to explain each structure in one or two sentences. Okay, that if you are doing this way, you will get four marks complete. Okay, now next, design questions. Uh, See the first, since it is a tension member, the its load is not given. See, if load is not given in the numericals, then you are able to calculate that load by using the formula given in the code. Okay, that formula is tension force. TDG is equal to AGFY by gamma m0 means partial safety factor, which is given on 6.2 page 32. See, I will show you the copy of IS code, which is, I have a hyperlink over here. Just wait, it is opening. Yes, PDF of the code is opening now. It is visible to you. Yes, see, this is the IS copy of IS 800/2007, Indian Standard General Construction in Steel Code of Practice, 3rd revision. Okay, now see, we have to see these are the its content, chapter 1 to materials, general requirements, and whatever what that load calculation formula we have to discuss, that is given in page number 32. That is the section number 6 of IS 800/2007 for that tension member. Page number 32. Yes, 33 and this is 32. This is the section 6, 32. This is 6.2. TDG is equal to AGFY by partial safety factor, where FY is yield stress of the material, AG is gross area, and gamma m0 is a partial safety factor for yielding from table number 5. See, table number 5 is here. Table number 5, partial safety factor for material gamma m, resistance governed by yielding gamma m0 1.1, resistance governed by buckling, it is again gamma 0 1.1, and resistance governed by ultimate gamma m1 is 1.25, and these are the partial safety factor for connections. Okay, so when we are for welding and for welded connections, which is for shop fabrication and field fabrication. Okay, so gamma m0 we have to pick up from here. So this is from this. FY is 250, then AG gross area from for the area we have to refer the steel table, and from steel table area for single angle section is given as 1047. There was these two angles are given in the problem, so 2 into 1047. So this is the 2094 is the area for double angle section for 2 ISA 90 by 90 by 6. Okay, then yield stress 250 MPa, table 1. Okay, it is over. Now gamma m0 partial safety factor 1.1 from table 5 IS 800/2007. Then TDG is equal to 2 into 1047, to area for two angles 250 1.5, it comes out to be 475.9 kilonewton. Okay, now we are going to assume the diameter of bolt. So diameter of bolt is I have assumed here 20 mm of grade 4.6. Therefore pitch is 2.5 times diameter of bolt, that is 2.5 into, it is again given in the code, 2.5 into 20, that is 50 mm. Then diameter of hole d0 is equal to diameter of bolt plus clearance that we have to follow, is 22, which is again that section 10 of table 19, section 10 of table 19. Just I will show you that table section 10 connection. So this is the section number 10. This is section number 10, which is entirely devoted for connections, so welded as well as bolted connections. This is table number 19 for clearance for fastener holes. These are the sizes: 12 to 14 mm, 1 mm clearance, 16 to 22, 2 mm clearance, and if it is 24, then it is again 2. If it is more than 24, then 3 mm clearance we have to take into the for D0. Okay, now next that our VDSB and VDPB. See the shear capacity of bolt VDSB is equal to VNSB by gamma MB, and VNSB is equal to FU by root 3 NN ANB plus NS into ASB. Okay, this is for shear capacity of bolt. And then for VDPB, bearing 10.3.4, bearing capacity of bolt VDPB is equal to VNPB by gamma MB, and VNPB is equal to 2.5 kb d into T into FU. D is diameter of bolt, T is thickness, FU is ultimate tensile strength of the material, FUB for bolt and FU for material section, and KB is the minimum of this 4. Okay, now just discuss our presentation. See this pitch is over, diameter of hole is over, end distance 1.5 times D0, which comes out to be 33. So we have taken is 35. So in case of double angle back to back, see this is the situation for double angle. This is one angle, this is another angle, and there is a gusset plate. These are connected together by the bolt. Okay, this is the cross sections. Okay, now it is you see the double angle back to back. It is going to fail in double shear because see it is acting like a bird joint. One plate, this is another plate, there is a gusset plate. Okay, this is angle leg width, this is another leg width, corrected leg width, and this is the gusset plate. Okay, clause 10.3.3, page 75 of IS 227, design shear capacity of bolt. Just now we have seen in the code VDSB is equal to VNSB by gamma MB, and VNSB is equal to FU by root 3 NN ANB plus NS into ASB. This is NN number of shear planes including threads, net area of bolt, NS number of shear planes in shank area, and ASB is the area of shank bolt. Okay, since NS is 0 because we are considering bolt is completely threaded, this becomes 0. Okay, FU is 400, NN 2 because double shear, A and B net area of bolt is 0.78 pi by 420 square, 245 mm square, NS 0, ASB 314. From this, just put all the values in these equations. We will get VNSB, that is net shear capacity. Now divided by net shear, we will get design shear capacity. VDSB is equal to VNSB by gamma MB, which is 90.53. Now next is design bearing strength. VDPB is equal to VNPB by gamma MB. So VNPB is equal to 2.5 kb into diameter of bolt into thickness into FU. Now everything is okay here. Just think about the thickness because it is a double angle. So in this case, T is equal to thickness of two angles or gusset plate, whichever is minimum. See, we have two angles, so angle thickness is 6 mm, so 6 plus 6, 12, and thickness of gusset plate is 8 mm. So from 12 and 8 we have to take is minimum, that is 8 mm. Okay, D is 20, FU is 400. So we will calculate KB. KB is minimum of this 3. E divided by 3 times diameter of hole, so it comes up to be 35. See, E 33 has come, we are round up it to 35. So it comes out to 0.53. Second criteria, P divided by 3 times D0 minus 0.25, it comes out to 0.5. Third is FUB by FU. FUB for bolt ultimate stress, and FU is the material that section ultimate strength. So it comes out 0.97, and last is 1. Therefore KB is minimum in 0.5. So therefore VNPB is equal to 80 kilonewton nominal. Now design bearing strength 80 by 1.25, partial safety factor is 64. Okay, now we have two values of failure criteria, VDSB and VDPB. So which we have to pick up? Minimum, because not maximum, because at minimum our bolt is going to be fail, not for maximum. Okay, please make sure. Therefore list bolt value is minimum of VDSB and VDPB. It is 64. Therefore number of bolt is equal to factor tension or factor design bolt divided by list bolt value. Design tension we have already calculated in step number 1 by TDG formula, that comes out to 475 divided by list bolt value 64, so it comes out to 7.44. therefore make it as 8 numbers. Okay, now after doing this, now see, we have assumed the diameter of bolt, we have assumed the grade of bolt, and we have calculated the number of bolts. Now after doing all these things, we have calculated the end distance and pitch distance. Now we have to show it on drawings. So this is the structural data. These are very important. Okay, because it will indicate all your whatever you have solved in the numerical, that all you have to represent over here. Okay, so this is the cross sections, this is gusset plate, this is double angles, 2 ISA 90 by 90 by 6, Okay, in elevation it is looking like this. This is your gusset plate. These are the 8 numbers you have calculated: 1 2 3 4 5 6 7 8, and this is the your end distance 35, and this is the pitch, center to center distance between the bolt in the direction of stress. Okay, so this is called as the design of connections. Okay, so we have covered both the problems: design of lap joint, butt joints, and design of angle section problem. Okay, so this way design of simple bolted connection is over. In next lectures I am going to cover the analysis and design of tension member, okay, which is again a very interesting topic. Okay, thank you.